Okay, so if we're looking at number 5 here, we have secant x plus 1 and secant x minus 1 over sine squared x. So I would probably suggest on this one that this is factored. Well, maybe it doesn't need to be factored. So what if we distribute it here? So we distributed secant x times secant x. We get secant squared x, right? Secant x times a negative 1 is a minus secant x. 1 times secant x, so we get a plus secant x. And a minus 1. And that's over sine squared x. So if we combine like terms here, secant x and secant x, that cancels out. So we have secant squared x minus 1 over sine squared x. Okay, so now we got to think about over here. Go back over here. So usually when we're thinking of, when we have stuff like this, we're looking at these Pythagorean identities. So secant squared x and 1. Well, if you think about this bottom one here, if we subtracted 1 over, we would have a minus 1, right? We could rewrite this as tan squared x, or tan squared theta equals secant squared theta minus 1, which is what we're going to do over here. So secant squared x minus 1 is the same as tan squared theta. So we have tan squared x, sorry, we're using x's here, over sine squared x. So then think back to what we did at the beginning. We want to write this, separate this. So I want this to be tan squared x over 1 times, and then I'm going to rewrite this as 1 over sine squared x. 1, 1, right, 1, 1. And then could we change this so that tan squared is in terms of sine squared? Which, yes, we can, right? Sine squared x over cosine squared x times 1 over sine squared x. You're always looking to change this. You're always looking for things to mark off. We did that so that these sine squared x's will mark off. So we are left with 1 over cosine squared x, which is secant squared x.